Welcome to the virtual day. And today we are introducing to you about the robotics and computer engineering curriculum. And this is Heiki Kasemägi. He is our program manager or director. And I am Mariana Cook, and I am from the marketing team. And also Reiko Raudmäe, who is our PhD student, is also coming here in a minute. So we should start. And Heiki, floor is yours at the moment.
Okay, thank you. I'm going to give you a brief overview about first Estonia, then Tartu, then Tartu University, and then our curriculum. Because I don't expect you to know anything about all those 3 or 4. Estonia is a small country situated in northeast corner of Europe. Is compared to smallest European countries like Holland. The population is so small that we claim that once 1/4 of a population were covered to that field. Of course, we have euro as a currency. This is a picture of our capital on a shore of lake between Estonia and Finland. And Estonia is a member of European Union and NATO since 2004. Tartu is second biggest city of Estonia and situated southeast from Tallinn, roughly 200 kilometers, on banks of small river called Emajõgi or Mother River. In the middle, you can actually see one of the university's buildings next to this arc bridge. This is the center of Tartu. The population is roughly 100,000, including the students, because in Tartu we have 2 universities. And you can see town square in the middle, and university's main building bit right up from the town square. And the history dates back to 1030 when one rulers of Ukraine came and burnt down the local castle. Now about the university. It was founded in 1632 by one of the Swedish kings. We have roughly 14,000 students, and also foreign students, PhD students. The university is divided into 4 faculties, which are arts and humanities, social sciences, medicine, and science and technology, and the later one is our faculty. The faculties are divided into institutes according to the specialties. We have currently 11 institutes, and Institute of Technology is the one that hosts our curriculum. And here you can see the backside of our institute's building. This is a nice one because the front side, it's not easy to have a look at it because the area is covered with private houses in front of it. And small overview the buildings around us. We have Chemicum, we have Physicum, we have Biomedicum, this is a biomedical center. And soon we're going to have our new building next to Physicum to the left. So, about our curriculum. As all curricula in the world, ours is also divided into parts. The first one is a basic module, it's mandatory. When the seminar module follows, it is also mandatory. It consists of a master seminar and some internal internship. When the specialization module follows, it is divided in between 3 specialties. You can choose between robotics, computer engineering, or space technology. When comes narrow field module, you can choose between practical training module, management module, economy, or semester abroad. Practical training is internship on our field, but being straightforward, it is going to work. You have to find a place to work, and you should also put the salary for that. It is roughly 4 months full time or 8 months half time. When you have 6 ECTS of optional courses, which you can choose freely, no one can tell you what courses you have to take. And it all ends with master thesis, worth of 30 ECTS. Now, regarding the specialization module and narrow field module, there is an option that if you are not interested, none of narrow field module options, you can pick 2 specialization modules. This means that 48 ECTS, or even combine the courses from all 3 specialization modules, as long as you have 48 ECTS at the end. So basically, you can put together your own kind of specialization path. There is a list of some of our courses we offer in autumn. This includes basic robotics, robotics competition, both land robots and drones. You can take courses in machine learning, parallel computing. Also, if you're interested in quantum computing, you can take courses in that topic. Of course, space-related courses. What else? Data acquisition and signal processing, soft robotics. More about robotics, like robotics technology, which is a ROS course. You can do digital image processing. For example, software-defined radio. And also you can take courses related to autonomous vehicles. I leave here some practical tips if you're interested how to manage in Tartu. And if you have explored our admission conditions, then you're probably aware of that you have to go through admission test. And these are the conditions for admission test. They are listed also in the beginning of a test. But basically, you can take it only once. Even if you have power or internet cutoff, there are no other attempts. Once you start it, you can only finish it. You can only move forward with questions, and there is no way you can return to previous questions. The test has overall time limit. You cannot exceed. If you exceed it, the test closes, but all your answers will be saved automatically and will be evaluated. The questions are in arbitrary order. The degree of complexity is different, and you have to kind of evaluate the time what you may spend on a single question. The questions are related to physics, electronics, mathematics, and programming. We will not give any more detailed information about the content of a test. Basically, everything you have learned so far should help you in that. I can give you no more specific recommendations how to prepare for a test. That's basically it. So, a brief overview what we are. I'm used to say that our curriculum stands on 3 pillars, and all 3 are in those pictures. It means that we rely on programming, electronics, and mechanics. And using those 3, you can put together a spaceship. You can make robots. You can basically do all those interesting gadgets you can see in exhibitions. And of course, you use lots of them. Here is a sample of electronic project. It is it's in soil, which you put in your shoe, and this records the pressure of your foot. And in principle, it can give you online or real-time feedback how to step or run if your foot is in the right position. Of course, you can record all the data, analyze it later. There are some examples of our electronic labs. We have 2 types of robots in use. In the left, you have you can see kind of it's a manipulator, but it's commercial manipulator. But in the right, you can see a robot which is our own creation, and one of authors is sitting in the right. Renno is one of the authors of this robot. So basically, we build robots. Also, not only our science lab, but in the right, you can see the robot made by first-year bachelor students after the first semester. This is a firefighter in principle. Our students made this cube satellite called S-Cube-1, which is by now finished its job, and in 20 years it will burn in Earth atmosphere. This big white wing is it's a place where people can work and live in hazardous conditions. For example, in the middle of forest fires, or basically, it is called Mars House. Of course, this kind of thing will never land on Mars, but if it's packed its size is of a sea container, which you can see on a boat of ships, which brings goods from one country to another. And if it's unpacked, it gives a place for 2-3 people to live and to work. Also, we are involved in a discipline called soft robotics. And our main target is electronics and control systems for these materials. These are called artificial muscles. It's basically a piece of rubber but if you apply electric current, it will bend and it can keep its position. If you reverse the polarity, it moves another direction. And this gives lots of opportunities because these are silent, sometimes really fast. Sometimes they can carry more than their own weight. Basically interesting materials. Of course, we can get without 3D printing. We have lots of them. Renno is in charge of those. And we not only print the plastic, but our science labs also print other types of materials, sometimes liquid-like, sometimes gel-like, for science purposes. As I mentioned, that you can take courses in autonomous vehicles. This is one of examples of from Estonian industry. Something like 10 years ago in our own parking yard. But also there is a Lexus autonomous vehicle where you can test, collect data, and give your part of his wheel. Of course, smart solutions, everything what is wireless and related to smart house, IoT. In the left, you can see our course kit, where you can what you can use for connections and connect different sensors, data. And at the right, there is a student version of smart mirror, which gives you information, let's say in a bathroom, and also acts like a mirror. Couple of more examples from student projects. In front there is one of the most popular smart solutions, which is basically greenhouse or click and grow, autonomous way to grow plants. And yes, you're welcome. And now Marianna takes over.
So thank you, Heiki. And maybe do you have any questions?
Yes,
do you have? Yeah.
This one. Yes, there are opportunities for robotics and programming. These job opportunities are located in Tartu and in Tallinn. Yes, in Viljandi also. So basically, yes, you can find an internship, sometimes even job while you study.
Also, we are organizing career days for our students, and also it's very, very useful for our students. But do you have any questions more at the moment? Or maybe Renno can give you a short overview about his studies at our institute. What was hard for you as a student, because you came from the different university, because you started your bachelor at the University of Life Science or something like that. Yeah, maybe you can give a short overview. Yeah.
So hello, my name is Renno, as they mentioned. At the moment, I'm a PhD student in computer engineering, but before
first year.
First year, yeah. So I just had attestation. I hope I passed. I didn't see it yet, but I came to masters in 2015, I guess. And the hardest part for me was definitely programming, because my background is more into mechanics, and yeah, I had to make myself aware about Python and C++ a bit, and C as well, because C you use with embedded systems. So that was the most difficult part for me. Any other parts, I guess they were not so difficult, especially the robotics part. I guess I quite fast found the place in here as a mechanics guy. And now I'm leading the course like Technical Graphics 1 and Technical Graphics 2, which you can take. One is in autumn semester, the other one is in spring semester. And at the moment, I'm quite greatly involved with most of the mechanical and electromechanical projects in the lab. But yeah, the most difficult one was programming. So make yourself, how to say, like get yourself used with some languages at least. English is the one language as well, but because if your tests are not good enough, I have to say that I was not really good student at high school, so I completely failed my English exam. So I couldn't get in because of English at first, because you have to have B2 level and you really need it. Although I was speaking English everyday basis, my papers didn't show that I could speak English at all. So I took TOEFL IPT, which was quite beneficial for me when I ended up in here. What else? I think most of the thing, like as Heiki said, is pretty flexible. That if you see that these things don't work out for you and you see some interesting courses, then it's up to you to form your future and put interesting things from economics or from IT Institute or whatever. You can put these things together, so you don't have to at some parts you have to struggle, because that's the part of the university, like come on. But if you see that you struggle and it's not beneficial for you at all, then you just have to speak up, like, because we all the time collect feedback and ask like what's going on and what's the base case for you and why you think like that. And we don't take all the students' opinion like the pure honest feedback. We filter it sometimes, but it's still like we understand if the core is not about the student is not capable for that, that the core is somewhere else, that maybe this subject is not the best for us and so on. So we are developing this everyday basis all the time, and in cooperation with the students. So what I would like to say is, like, if you come here as a student, then you quite quickly realize that if you speak up, then we will find a job for you, and or we will find a place for you. Like, don't worry about that. So because we need like people who like to deal with the technology. So yeah, I would say that if you have enough motivation, then everything is possible, and you have to be interested about the topic. So that's my honest answer. I'm speaking so much, but like the thing is, I've heard from people sometimes that they're coming to study IT or the hardware side because they heard that there is lots of money in there. Yes, of course, everywhere is lots of money. But if you're not interested about it, then you will get tired of it after 2 years, and that's the thing. But if this is your passion, then no worries. And everything is possible to do it, even if you are a bad programmer at the beginning. Yeah, okay.
But Ren, maybe you can give a short overview about the cool projects, but you are involved about the Robotoint and the Semubot and so on.
Yeah, as Mariana said, those are the two basic projects. Robotoint, what Heiki also showed on the slides, is the wheeled base, what you can use for programming the ROS, which is also mentioned at some places. So that's the platform to teach high-level robotics like self-driving cars and so on. And we did it because we saw that there is nothing like that on the market. Yeah, the same one.
So it's the first generation, or
it's the second. It's the second one. Yeah, and the third generation is 3D printed one already. So and this is fully open source. You can go and check it out to robotoint.ut.ee. There is like over 20 20 theses written on top of this project, and I was also the master student, and this was pretty much my master thesis, to put this all the mechanics side, all the concept and this kind of things together. Of course, I had lots of helpers, and my supervisors Veiko and Karl did much work. Veiko most of the programming side. But at the beginning, when I started with the generation 1, then I was actually quite, I would say, lonely. So I had to deal with everything, had to do the workshops and so on. So this is one wheelbase what we are using for basically every other project where we are working on, and that's one of the most reliable platforms what we use for our demos. Like if you need to, like, I have something that I need demo, it's like I take my docs and after 5 minutes it runs. So that's a cool thing what we have developed. And the other thing is Semubot, humanoid social robot. What we are developing at the moment together with like higher applied science Pallas school and some people from other universities as well. So the idea is to make a humanoid robot which is social. And the first pilot thing will be held in the Children's Hospital, where we use at the moment robot Pepper, which is also developed together with our scientists and made this to speak Estonian. And it's been a while. It's been a quite big hack to make the closed source things in such a way. But we want to make open source social robots. So if something goes broken or something like that, then something fails, then you don't have to send this to somewhere and do a warranty. You can fix this on site because everything blueprints and everything will be available. So at the same time, you don't have to keep like one robot in the corner that if one fails, then I take another one. Like it's just with old computers that you take another one and you continue your work. Instead of this, you can fix minor errors on site or talk with our technicians that, okay, I just do these things. So, and the bigger plan is, of course, some like elderly homes, and why not to make them leading the way in the mazes, like in the hospital is a quite big maze, so it's kind of hard to find some doors in there. And instead of this, that doctors, or not the doctors, but these sisters, how to call them in English, nurses, they lead the way. They could be robots, because robots could treat that as the same way. And that's also one project where I led now, is that we have piloted some robots in hospitals that they lead the way where to go, and also take the samples from one apartment to another. So instead of humans who could invest their time in a better way, there could be robots instead of this. So yeah, these are some cool projects. Like yeah, this Mars house was one of the coolest projects that we had. We had Fits Me like long years ago. Janu, it's a robot bartender, serves drinks, and let's see how far this AI gets at one day. But the biggest idea that it will crack a joke and talk with you, and so the idea is that you can order your drink. I don't know, Tom Collins from the app, and you can go and take it from the place where it handed it up. So you can Google it, Janu with I, like something. So and there is some like climate things. I think there is this not the ventilation system, but so basically it detects how much CO is in the air, and it starts to filter the air and give you the pure air. And now there is a big production going on with this. So there are, from time to time, there are cool projects are going on, and if Mariana asks like, oh, what cool projects are you doing? Like, oh, let me see, today or like last week or last year. So
or for the future as well.
Or for the future as well. So it's kind of hard to remember everything what to do on everyday basis. Yeah.
And Heiki, this Tuesday, our students defender their master thesis. Maybe you can, I don't know, give some short overview about the thesis, what they are doing.
Mostly they were related to artificial intelligence. Machine learning was almost in every thesis. Yes. It is kind of popular right now.
I think that also shows how fast things adapt. Because a few years ago we were only talking about AI, but now we are already using it. So the technology develops and we have to adapt with it.
Okay, we have one question here. Are there any scholarship or tutor viewers specific to this program? We have tutor viewer for one student outside Estonia and European Union. More seats for Estonian and European Union citizens. What else?
Any questions more from there?
Maybe do you have any questions about Estonia or about Tartu, or I don't know? No questions?
Maybe I just briefly talk about the labs or the equipment what we have, because Heiki showed like one of the.
Also, we had DigiLab as well.
Yes, sorry to say, but you showed like quite one of the oldest printer what we have. But we have like about 8 Prusa i3 printers, which is also quite old now, but it works like perfectly. So just buy a Prusa and you forget that you had to repair the printer. But of course, we do the maintenance and so on, because every year we buy so much filament that, and we prototyping. So, and we have also later machines like turning machines, CNC milling machines, laser cutting machines. We have at the moment we have equipment in 3 houses in Physicum in North 1 and also in the center of the city. But they are going to be moved into the new house, which will appear hopefully within 5 years. Let's see. To support students' work like the final thesis or your at some point also your own like cool projects. I'm fully supportive in such cases that like you have a nice idea, we have equipment, let's try it out, why not? So, and I try to support students during my subject as well in technical graphics, where we learn how to use SolidWorks. After that, it's possible to get also the CSVA certificate that you're a certified SolidWorks user. What else? So, like, I'm more that guy like who is supporting the hands-on things, and I guess like most of the people from our teachers, they are in such that if it's not practical, then it might not be useful at all. So why the hell do we do something? So we are not doing science because of science. We do the science because it's needed to develop new things.
And Renno mentioned the lab called DigiLab. This is not a study lab, but specifically it's a lab for students where a student can work on their own projects, either study related or their own hobby projects. If it goes into a commercial scale, then we have to see what how we going to continue. But as long as it's a small scale, everything is welcome. And more questions? I studied computer science. How much of electronics and mechanics do I need to study your master? Well, it's up to you how fast learner you are, and what is your plans for the future. if you need electronics or mechanics, then you have to study it. And basically you can do any of modern devices without electronics. And this probably not concerns you, but you have to know programming. You must how to say, you must be able to program. It doesn't matter what is the language, because it's just a matter of syntax, but you should know the principles of programming and should be able to create your own programs. Without it, it will be really, really difficult, because everything is related to programming.
I think it's also up to you, but it's possible to take some bachelor courses which are quite beneficial, like electronical, like production and design. I would say it's one of the beneficial courses. Not a very huge course, but you will get to know some basics of electronics and how to design them and so on. And but there are plenty of at least at some level that you understand which is resistor, which is a capacitor, and which is a LED, and so that you don't mix up like so easy things. But this is just a matter of watching 3 YouTube videos or something.
But yes, in principle, if you look at our admission conditions,
you have to
expect at least some knowledge in electronics, not in robotics, but in programming, in physics, in math. In modern world, the programming is another foreign language. You must know. Okay, another question. The lab sounds quite interesting. Thank you. I have seen that Tartu is a small city. Do you think it will be difficult to find an internship in Tartu, or is it more likely that I will have to travel to Tallinn? I guess there are lots of opportunities in Tartu, either in programming path or in hardware part. I have to emphasize that our curriculum is mostly hardware oriented. We use programming as a necessary tool to put the hardware to work. We are not concentrated on programming as such. So I guess you can do your internship in Tartu, but since this internship course lasts for 4 months, it means basically a whole semester. It's 24 ECTS. You can travel to Tallinn also. Sometimes people go abroad to other countries to do this internship in companies all over Europe. So there are lots of opportunities. And for example, if you use Erasmus possibilities, then you can get funding from there.
Okay, but do you have any questions to Heiki or Renno, or maybe you would like to add something for them? Because Heiki, what do you think? What is the most important task what they have to done before they are applying the curriculum exactly? What they had to think about it before?
Well, as I mentioned, evaluate your programming skills. Look at your electronic knowledge. Look at your math knowledge. These are basics in our field, more or less.
I have another recommendation.
Okay, go ahead.
Do something with your own hands.
Yes.
So basically, it can be anything like it as like electronics programming and so on. Like, so the easiest way to get started usually how people is that they take Arduino, put some random code there. But the next step is try to modify this one, and the third one is try to make this code yourself and try to modify the electronics as well. So that you take some applications from Instructables, from Thingiverse, or whatever place, and just try it through. Like if you scroll it through it, it's easy. I don't like why I should bother myself. Then actually try it through if it is so easy to do it in a real life, actually, because in a real life there exists many obstacles on the way, which from the slides they seem to be easy. So that's my thing. In general, if you want to become an engineer or something, then just start doing something. It's like even though if it's not like beneficial in the way that I can buy this from shop, like, but try to get into it and learn from it, like how this project was done, and because your brain will start to develop new ideas out of it. That's my recommendation for everybody who want to get into the engineering part.
And if you apply, don't forget to mention all those things that Renna just said, that if you have done some cool project, even perhaps you have published a paper, you have to mention it. It's must to mention it. All the cool projects you can point on. Maybe have some repositories in GitHub or somewhere else. And if you have somehow related to Tartu, if you have been here, for example, in summer schools, in the university, then you should mention it. It's a tip for participants here. It's not written in anywhere else. Okay, question. How many people approximately are currently studying this program? If we only look at our master program, it's roughly okay. Now 8 people graduate. It's roughly 40-45. The whole community of computer engineers and robotics people here is roughly 250, most of them bachelor students. But if you looked at the total number of students of the University of Tartu, it's approximately 13,000. Not that small, but not that big either. So average.
Heiki, I have one question.
Okay.
Usually, students are asking from me, Mariana, why University of Tartu is better than TalTech? Because actually, it's the main question what they're asking from my side. So actually, also we have TalTech. It's like Tallinn University of Technology. But why they have to come to Tartu? Why Tartu is better? Usually they are asking from me this question. I don't know why.
The difference is actually not that one is better than another, but the difference is in orientation. In Tartu, in our curriculum, you can get academic degree. In Tallinn, you also get an academic degree, but it's you get education of engineer, and these are two different things. If you graduate our curriculum, we assume that you are a person who can do web learning. You can adapt in different conditions in workplace. You can be innovative, bring in new solutions, new ways to work, to do things. Engineers, they have to follow kind of strict rules how to make things in order that they don't break if a first bird comes in and knocks. That is a main difference.
I would say, but from in general, from the student side, Tartu is better. So because
it's the student city.
Yeah, it's a student city. Like that, if we have the student days, then actually there are student days, and in Tallinn as well. I don't say that there are not, but Tallinn as a city is more spread, and the student community is not so huge in there. So if you are coming to Tartu as a student, then you really feel like you're a student. If you're in Tallinn, then you're just another guy who goes to work, but instead of going to work, he or she is going to at university. So that's what I have felt like in such a way. And also, if I compare the academical organizations like Estonian ones, then I know that we have part in Tartu, and we have I'm part of Tartu community, and we have part in Tallinn. But it's really hard to get people in there because it's somewhere in the center, and people they are coming from all over the Tallinn, and distances in Tallinn are larger. If you compare the big cities in the world, of course, it's not nothing. But in Tartu, you can basically go everywhere by foot or with bicycle. You don't have to own the car. So, like the student life is definitely one of the key things. I haven't studied in Taltech, but I know a few people there who have. As Heiki said, that the mindset is somewhat different, but somewhat we do similar things, as they do also ROS, and we do ROS, and actually we communicate with each other because Estonia is too small to have like a competition in such kind of things. So as the word vocabulary for ROS vocabulary to bring in Estonia, we all the time cooperate with Taltech as well. So there is no such thing that we that's like they are there and we're here. Of course, like there is some teaching, but at some basis we are really on the same making cooperation as well. Yeah, I don't.
One thing I have to add that you can also participate in a solar car race. If you have heard about Solar Ride, which were held at the end of last year in Australia, where we had to cover 3,000 kilometers through Australia, when lots of our students participated in a race in Australia. And it's an ongoing project, and everyone can join, and which is actually connects the universities all over Estonia.
Yeah.
So in 2025, they are going to Australia again. So you have time to prepare for the competition.
And those alumni of the Solar Ride, they have a list of offers on their door, like where they could work. And if I would mention some cool startups from Estonia, then most of the places they have my course mates are working in there, or some other computer engineers who have graduated and didn't want to stay at university. So, but I feel it's like so cool to be here. So since so because all the time everything new and so on. But yeah, about job offers, like I see that if you graduate the computer engineering, you don't have any problem to get another.
Not at all.
Yep.
And if you can't get any job offers, you can start your own company.
Yeah,
basically.
That's also an option. That's what our students have also made, quite many of them.
Or you can start your PhD position as well, like you did.
Yeah.
Because we cover all three levels of higher education, starting from bachelor's up to PhD.
But okay, do you have any final question to us? As a marketer, I would like to say that if you are coming to Estonia, then Tartu is our cultural capital in Europe, and lots of events will be held in this year. So if you are coming to Estonia, then and also Tartu, it will be super fantastic because lots of events are coming to
Tämä sama saa huomioon nämä vinkels.
So if you don't have any questions, then application deadline is 15th of March. And so what time you are letting them know that they can come to University of
I'm
Tartu?
not even sure about it.
30th of April or something.
Yeah, you have to check it from university website, what they have put there.
So you can think about it until 15th of March. And yeah, if you also have any questions, you can write directly to our program director, Heiki Kasemägi, and also he will answer everything. But yeah, thank you for being here, and yeah, have a nice day from our side. Bye.
See you.
Bye. Stop. Nii tehtud.
Meid kindla